So here we've got a question. We've got a truck company, runs between two cities, and the distance is 250 kilometers. So as you read it, make sure you understand that, right? The truck runs at velocity v, and the cost per hour is 6,400 plus v cents. So basically, the longer you run the truck, the more it costs you, because, you know, you have to pay for the people or anything, right? Basically, there's a cost per hour component. And you're asked to show that the trip, which is 250 kilometers long, will cost this much. So based on the information given, this is basically leading you through it and saying, okay, do step 2, right? This is step 1, we've read the question. This is step 2, find C, which is what we want to minimize ultimately, in terms of the variable V, which is what we're changing. We can run the truck faster, or we can run the truck slower, right? So you can probably see that if we run the truck really slow, what happens to the time?
It increases.
It increases, but, you know, but the cost per hour is kind of lower because you save on fuel, I guess, right? So basically, we could either run the truck really fast and get there really quickly, but it costs us a lot to do that in terms of fuel, in a way, or kind of go the other way, and some sort of variation in between. Does that make sense? So do you guys understand essentially like how we work out this cost? So we said last time for a volume of a rectangular prism, it's length times width times height, and then we went ahead and tried to work out what that was. It generally, in terms of the cost that they're given here, how would we work out the cost of this trip? Considering the information given, we've got a cost per hour, right? So to get the cost from cost per hour, what do we do? Think of what cost per hour means, right? Cost per hour is how much it costs you per hour. So to get to the total cost, you need to multiply by?
By the hours.
By the number of hours. And that's what I mean by, you know, don't think overcomplicate or anything. Just figure out, you know, from the volume, don't worry about the X yet, right? The volume was just, you know, length times width times height. And then you know, find each one in terms of X or whatever. But here it's just, you know, cost per hour. And then you just multiply the number of hours, right? Now, cost per hour is directly given to you in terms of V already. So that's nice and easy. You don't need to do anything there. But our next job is to find the number of hours. Now, what is, like when I say number of hours, what's another way to put that?
250 minus V kilometers per hour.
Wait,
Well, that doesn't make sense.
Number of hours is really the time, right?
Right.
In hours. And how do I work out time from the information I've got?
250 divided by V.
Right. You know, just your basic primary school, right? The time is distance over speed. And so here, your distance is in kilometers. So pay attention to units as well for these questions. But because it's 250 kilometers and you've got, you know, V kilometers per hour, then it works out. And so this will just be 250 over V. Does that make sense? This is basically time taken for the trip. And then if you compare against what you want over here, it's basically the same thing, but you just divide it by V throughout. So we do that and we're done. And that's A.
Nice.
Make sense? Any questions?
No.
All right. Well, then the rest is your calculus. I don't imagine you'll have too much trouble with that. So what do we do? First thing, we would find the first derivative. Now, I assume you guys are comfortable enough with working out the first derivative at this point, so I won't go through it, but basically, you just change the form, right? So it's going to be negative 600 over v squared plus 1, all right? So that's your first derivative, okay? And then we want that to equal 0, and we solve for v, which would then be equivalent to v squared equals 6,400. So v would therefore equal 80 kilometers per hour. So at this point in time, we found that when v equals 80, you've got a stationary point. Now, have we shown it's a minimum yet? Have we shown it's a minimum?
No.
No. And so we need to do what?
Second derivative.
Right. And so if we take the second derivative, then you'll find it's something like that. And then you need to sub in your 80. And if you do that, I mean, it really doesn't matter what the number is, but for exam purposes, we often need to write the number. But you can probably see it's going to be a positive number, right? Because, positive, 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 right? And it's really, whether it's positive or negative that matters, not, the number itself. But the point is, at this point, the first derivative is 0, the second derivative is positive, which means it's a maximum or a minimum. Second derivative is positive.
Minimum.
And therefore, we're done with B. Does it make sense? Is that clear? And lastly, how do we find the actual minimum cost? So we actually, need to answer the question for minimum cost now. How do I do that?
The minimum cost to go at all?
I want to actually find the minimum cost itself. So how much it costs.
You just sub the 80 into the original formula.
Exactly. So we already have it in terms of V. We just need to sub it in. Now, remember, it's in terms of cents. So once you, work it out, it's in terms of cents. So you just sub it in. So it's 250 times 6400 over 80 plus 80. Well, that looks like it's actually going to be 250 times 160, which will just be 40,000. But that's in cents. So I guess it's $400. And that's basically how you would do a max min question. And really, this, the first derivative, second derivative part doesn't really change, right? The variations might be on domain, which basically don't happen with SL. But the variation that happens more is kind of in sort of the whole how to find the sort of formula part, which you guys have said generally you won't have trouble with. So that's good. And that first part has nothing to do with the calculus itself. So get a bit more practice done. But yeah, basically that's the gist of max min questions.